Good morning, fellow programmers. Thanks for joining me. I'm T-Pain, and welcome to Let's Learn Python. Feel free to use the skip ahead feature on the right-hand side to jump to any specific sections or examples. Today we'll be using Python 2.7.6 and Python 3.4.2, which you can download from python.org/downloads. So you've heard of werewolves. Well, today we're going to be focusing on werebears and werebears ours. We'll also be discussing how it doesn't make any physiological sense on how a person can gain 300 pounds of mass out of thin air. I'm looking at you, Hulk. Alright, enough goofing around. Okay, so today is actually going to be about the solutions for Let's Learn Python tutorials 17 through 24. So let's begin. I have the challenges from lesson 17 open right here. The solutions file is going to be provided with a link in the description, so you can download the code yourself. And that is through GitHub. Okay, so let's open the solutions for 17. All right. Question 1. What are the two ways to check what type of object we are dealing with? There are two ways. You can use type, and you can use the __class _ to actually print out what type of object it is. So if we run our code real quick and scroll to the top, you'll see it's type string and type string. There may be other methods, but I am not aware of them. Number 2, can we set the base type of an object to be overridden? So can we override what type of class it is? I tried doing that right here with a simple try and except statement, and it failed. It actually was not able to convert a type to another type. So the only way I know of to actually change types is to override the variable altogether. I don't remember why I asked this question, but there it is. Number 3, create a class using the type method that inherits from a base class, which is also created from the type method. Okay? So that's just asking for a base class and subclass to be created using the type method. And there you go. And then we just print to make sure that everything's working correctly. Number 4, see if you can recreate the Metaclass Singleton from memory. This is way too tough, in my opinion, to do it from memory unless you've done it like a dozen times or so. So I just recommend using this code right here. Bam, there you go. And a minor note for Python 3 and up users, you can actually uncomment this first line, line 33, and then comment out lines 34 and 35 to actually have the code work for Python 3.0 and above. Otherwise, if you're using 2.7 or anything like that, this code will work just fine. And at the very end, we have some code to test everything. Perfect. Alright, so let's go ahead and move on to the next challenge. I'm going to close out this file and open up solutions for 18. So for challenges 18, first question says, add one more class to the final example. Okay, and we did that in line 23 with C3 is equal to blah blah blah. And then number 2 says, create a second base class that is inherited by C2 and C3, then create a factory function for that base class. So we did that up above here on line 5 and 6, where we just created another base class called base class 2, and we have it inherited by 2 and 3 right here in lines 22 and 23. Then create a factory function for the base class, and we have that down below on lines 30 through 34. And so that's my factory 2. And lastly, recreate the first example using old non-type methods. And so we scroll down here and we'll actually have the same code actually recreated, but using the classic class method here. And number 4, stay awesome. That's the most important question of all. How do we stay awesome? Just by being ourselves. Okay, that sounded really hokey. Moving on. Okay, so there's 3 different solutions for number 19. I did not specify what to add the triple quote description to, like if it was the first example, the light bulb, or the robot maid. So I actually included both of those with descriptions. So if we crack this open, all that's been added is just a nice little description of each one of these. Okay, and the same for the robot maid. Little description. Yeah, not that hard. Close those both down. And then we have number 2. It says create a robot cat which has 3 states: walk, sleep, and meow. The cat should transition to each state after an interval of time. So basically, I just copied the code from the robot maid, made some slight modifications to make it a cat, and everything transitions here, and yeah, it's just pretty much the exact same code as the robot made. And everything's been commented out and notated so that you know exactly what's going on. We have our transitions here, which are going to be transitioning between states. We have our state base class defined here, as well as the 3 different states that we need to create: the sleep, walk, and meow. And finally, we have our finite state machine here, which has the add transitions, add state functions, and so on and so forth. So if you want to look at this code closer detail, feel free to download it and examine it. And finally, at the very end, we just go ahead and test the code out. So if we actually want to test the code out, we'll just press Control B here in Sublime Text, and it'll just walk through, and it's walking, sometimes it's sleeping. It all depends on what it feels like doing. It's clearing throat, then it meows, which is really annoying, and then it's done. Cool. And just note, so all this code that I provided you will work in both versions of Python. Okay, let's move on to number 20. And close out this file and open up the solutions for number 20. And that's the solution for the A* method. Alright, add a description to all functions and classes that explains what each does. And so that's just like as before. We're adding simple descriptions of what's going on. Also here and here for all the functions. Okay. Do you think this function will work on a full sentence? If so, try it. And so I tested that. Let's scroll down to the bottom at lines 100 and on. And I just threw in a whole bunch of random letters, periods, and spaces to test if it would work, and switched them up. And let's see if it works. Oh my goodness, it works! Surprise! Alright. So it does it. The algorithm works beautifully, and it just organizes the letter how it should be, shifting around 2 at a time, and yeah, works flawlessly. Okay, so that's it for this challenge. Let's go on to number 21, and let's check out the code for 21. Open that up. And the challenge, the easy challenge is add a description, which we've done quite a few times now. This is just for beginners to really get a grasp of adding a description and thinking more deeply about what's going on with code and having to articulate it. So next one is medium. Increase the number of sticks that can be used to 3. All right, and the way that we do that is right here on line 21. This was originally a 3, and we just changed that to a 4 to now offer 3 different options, 1, 2, or 3. The other place that we changed the code is in the actual final lines where we're printing out what the options are for the player. And so right here we added or 3, and then in the choice I added the 2 or 3. Okay, and then the hard was to implement a alpha beta pruning method after increasing these sticks numbers. And so the way that we added that is here on line 50 and 51. And what we do is we do a simple check to see if we do indeed have the best possible value for that current player. And if we do, then we're just going to go ahead and break the loop, and then we'll return that value to basically say that that's the best possible move and avoid any further calculations. That's all. Okay, so that's it for exercise 21. Let's go ahead and move on to number 22. Okay, here we go for number 22. Now, this one was a bit more complex than all the past challenges. Easy says, read the 2 multi-threading interview questions. Yeah, that was just basically knowledge stuff, so there was no way to answer that. Use the clock method from the time module to determine how long it takes to complete the simple example program. Then create a non-multi-threading version of the program and time that. It will be faster, surprisingly. Alright, so for the solution for the medium part of the program, I went ahead and commented out lines 31 through 42 and uncommented out lines 46 through 53. Right here, 55, 6, and 7 are commented out just so that we can actually focus on the solution for the medium problem. Alright, and if we actually run our code, it'll work just as before in that it'll be mixing around words, and yeah. And so now if we want to actually compare the two, we're going to go ahead and uncomment out all those lines again. And now if we run the code, it'll actually output stuff very sporadically. First, it'll output all of our single thread code and output statements. Then it'll say exiting, and then it'll output all the thread statements. So those are actually going to be stacked on top of each other because they take a little longer to fire off and stuff. And so we'll see the multi-threading total time versus the single thread total time. And we'll actually see that the single thread is quite a bit faster than the multi-thread solution. And the reason that is because it's threads take a little longer to fire off, and so that information has to be transferred over to those different threads. And yeah. And again, this isn't complex code. If we did have like lots of complex code firing off on multiple threads, then it could perform much faster. Okay, so that's it for the solution for the medium problem. Now we get into the hard problem. Implement the join and lock methods of each new thread to the previous. Documentation links down below. Alright, so to implement the lock code, I actually blocked out this bit right here. Line 5 is actually the first bit of lock code, and it's just basically creating an instance of a lock object. And then right here in our function on line 8, we have global lock, and that's basically allowing this function to access that variable lock. That's what's going to allow us to enable and disable it across the different threads. Now, if I comment out lines 12 through 15, and then uncomment out lines 17 through 21, we actually have this with lock starting off our code. And what with is saying is that with is going to actually execute like a enter and exit function of the class instance right here. And that's going to allow us to enable or disable the lock functionality within the thread. When one thread is locked, it's actually going to stop all the other threads from being executed until this locked thread is no longer locked. So in other words, when this block of code right here, lines 18 through 21, are complete, then it'll allow the next thread to execute. And so what that'll actually allow is for them to all be done simultaneously. And I'm going to go back down and actually comment out this medium solution right here, lines 46 through 53. Comment those out. And I'm also going to comment out lines 56. So that was printing out the single thread total time. Okay, save it and run. Now notice what's happening. The main program is running through and completing, meanwhile the threads are actually taking their time in being output. So one thread is completed, then the next thread, then the next thread, and so on. This is after, so the threads are running even after the main program has completed. So how do we stop the main program from running while a thread is completing? Instead, we're actually going to use the join method. And so join here on line 38, if we uncomment that out, and then just so we can see what's going on, I'm going to recomment out line 17 through 21, and then uncomment out the original 12 through 15. Save that and run it. Now watch what happens. It prints line by line, and we're still stuck in the main block of code. And then once we finish out that final thread, then the program wraps up. So again, lock is to actually prevent other threads from completing processes and only focus on one. And join is to actually force the main program to wait until a thread is completed. All right, great work. That was an extremely complex solution for number 22, but these solutions get more and more complex as we go on to these harder and harder challenges. Okay, so let's close out number 22 and move on to number 23. All right, here we go. Let's open up number 23. So the easy part of the problem was to remove the greater than and less than titles from the actual output. So right now, if we were to run the program, they would actually be included. So the way that we cut that out is if we actually go back to our main code, scroll down, we can include these parentheses right here on line 25 around whatever it is that we want to be printed out. And that'll just, so that'll actually output whatever the header is for, or whatever the title is for the website. So if we run our code, and the output is MSN, Google with a capital G, CNN.com, and Yahoo. Okay? The medium part of the challenge is to implement multi-threading to run or call each of the website pages simultaneously. Okay, and the way that we do that is we actually separate out the code into a function, the bulk of the searching code. So we break it up to get name from URL. This will actually print out the completed blah blah blah, and yeah. So pretty much the whole thing is the solution for the medium problem. And it says, finally, after implementing the multi-threading, create a timer which determines how long each website takes to load, and share your results in the comments below. Hey! Alright, so the way that we do that is we just do a simple start clock, and then at the very end of line 18 we just include a current time, so we basically subtract the start time from the current time to get our total time. And now if we run the program, we'll see just how quickly each page loads. MSN outputs at the fastest time of 0.47, Google is at 0.73, CNN is at a speed of 1.33, and finally completes with the slowest time of 1.94. I thought that was fascinating. I don't know about you guys, but it's interesting to see who's fast and who's not so fast. Bonus question is to investigate RA match and RA search. You can do that on your own, just for more learning. Okay, so let's move on to challenge 24. Let's close out this page. So the solutions for number 24 are actually going to be a lot of different files, and they're all starting with 024, so that you know which ones they are. The ones that are the BAT files, those were just around for me to create files faster, to create the final file, the raw Python UI file, everything just much faster, and also to allow me to just double click and running a file. If we were to open up any of these, they're just simple commands like it would be like Python calling the final file to execute it and then pause to do any debugging I needed. These files on Mac and Linux wouldn't work. This is just strictly for Windows users. I'm lazy, what can I say? I just like to double click stuff, to make it executable. This is the easiest way I know how to. Easiest to add 2 more UI buttons and implement different print statements. So if we went ahead and ran the easy bat, what we'll end up with is this UI form right here. And so if we press print ham, it works. Print super ham, that works. And finally the print question mark, it says, my favorite smell is yellow. I don't know, I thought it was funny. Alright. And so that's it for the easy UI. Medium is create a Python script that opens another Python file automatically and adds the def print function and everything else we added to the UI file for the first example. A script that will help you develop scripts. Scriptception. Alright, and that's exactly what these files do. The easy adder is basically a single file that has a whole bunch of code in here that's going to be added to the appropriate points of our raw file. And so those will combine to actually create our final UI file. So when we execute it, everything will run. We see our beginning lines are this single line right here to make this Mac and Linux friendly. This line is import sys, which will allow us to close out the program when it's finished. Then we have these final lines, which are going to be our simple functions that are going to be attached to the class. Then we have our main execution code to check if this is the main file, and if it is, then we're just going to go ahead and run the code. Then we have our source raw file. So this was the file that was created straight from the UI file into fresh Python code using the pyuic4 command. We read in that file, then we close it, and then we split up the lines based on the single line that's class UI form inheriting from object. So this is where we're going to actually replace it with this constructor code down below, where we're actually going to be inheriting from the QWidget class and creating the constructor that's going to actually run the setup and init of the QWidget. Finally, we go ahead and open the file that's 024 sol easy file.py, and then we just begin pasting in that code. So again, this is all just simple scripting that'll actually create the final file for us, so that we won't have to add the same bit of code over and over to it. It'll automate it for us, which in my eyes is very cool and very lazy. I love to be lazy. Alright, and if we open up our raw file, which was created straight from the pyuic4 code, we'll actually see that we're still missing the import stuff. We've got everything set up here, and we're missing our functions to actually connect to the buttons. And so that's why we have everything automated with the easy adder. And it creates this final file, this easy final. And here we have our import code for import sys. We scroll down. This has all been replaced appropriately. We scroll down, and there is our code that is actually connecting our button functionality to actual print statements. And finally, our last bit of code to test everything. Oops, I keep dragging and dropping. Oops. All right, so there it is right there. Awesome. So then we get to the hard challenge, and this was indeed hard. So this part of the challenge was to actually create a working calculator, a simple calculator that was basically integers only, not including decimal points or anything like complex. It was just add, subtract, multiply, and divide functionality onto different integers like 0 through 9. Okay, so if we actually test out our code, we're going to go ahead and run the 024 run hard. Double click on that, and here is our simple calculator. Notice how it scales, everything's good. And if I punch in numbers, 1, 2, 3, all works good, plus 4, 5, 6, and then press the equal sign, and it'll give us our final output. And if we want to clear it, we just press clear. Everything works properly, times 87 times 6, enter it, and it executes everything awesomely. The way this magic actually works is Python has one of these functions that like not many other programming languages have. It's called eval. I may have covered it before, but it's worth noting again. So let's actually see what's going on. So I'm going to open up this. So I'm going to open up the hard final, scrolling down, and we'll see our main UI code is actually in lines 14 through something like 139, which is a lot of code. Then we connect our buttons to a bunch of functions that's actually going to be basically just adding a value, a string value of 1 or whatever the digit it's pressing onto the output. And the output is then going to be updating the text label. And so that's what's going to allow us to display everything, or display our current operations that are going to be happening. And so it's just going to be adding 1 or 2 or whatever it is, including the plus minus symbols. One minor thing that I did for the plus minus symbols is I wanted to make sure that we didn't actually like press like plus a bunch of times or minus a bunch of times, so that if we press times and press them multiple times, they can't actually like be compounded on each other. This was just a simple way of checking that the last operation is not like trying to override other stuff and break the script. Okay, and then after that, then we just update the text, and that's it for those. When we press the clear button, we're just setting everything to 0, and then when we press the equal sign, it's just going to use this function eval right here to evaluate the current output string as an actual like statement, so that if it was a string of 1 plus 1, then it would evaluate them as 1 plus 1, as if they were not a string. They were actually integers being added together. And then we convert that back to a string, and then we update the text. Scrolling down, the update text is just a slightly more complex than the past statements. So in the update text function, what we're doing is we're checking to see if the output has a length of 1, and if it does, to check to make sure that if the first digit is 0, that we remove that first digit. Then after that, we're going to go ahead and output that text to the label text. And that's it. Then we just have the final execution code. Beautiful. So that's it. All right, thank you so much for watching. Great job keeping up. Definitely take a few minutes of... we're not doing that. Please leave me a comment below if this helped you at all. And please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Also, hit the little likey like button if you want to show some love. And thank you so much for your support and keep the dream alive.